In this video, I want to talk about a function being one-to-one and how to find the inverse of a function. A function is said to be one-to-one if this holds true, meaning if a y value in a function equals a y value in a function, you know that the x values must have been the same. Well, this is kind of a confusing definition, but this is the real thing. What it means is that every y has only one x mapped to it. So, for example, let's say on my little graph of x squared, I pick x equal or a y value of 2. Well, if I said, what two values map to that, you'd say, well, the square root of 2 and the negative square root of 2. So this function is not one-to-one because a y value had this y value had two x values that map to it. And to be one-to-one, if you pick a y value, only one x maps to it. Now, the easiest way to check this is what's called the horizontal line test. And the horizontal line test simply says that if I can draw a horizontal line anywhere on a graph and touch the function more than once, it's not one-to-one. So here's some examples. Okay? Are these functions one-to-one? Of course, this one is not. This one is, anywhere I draw it. This one is not. Now, I want to quickly talk about this. This is the graph of tangent. And you may think to yourself, well, tangent, there's an inverse tangent function on my calculator. You can restrict the domain of a function so that it passes the horizontal line test. And actually on your calculator, if you did inverse tangent, it would ignore values over here and over here and would only return values between negative pi over 2 and pi over 2. Therefore, if you only look at this one part of the graph, then it certainly does have, it is one-to-one and has an inverse. But if you look at the whole function, it doesn't. Okay, going on down here, of course, this is a yes. This is a no, and this is a no. Now what these tell us, this no's and yes, is does the function have an inverse? It doesn't tell us what it is, it simply says does it have one. Because to have an inverse, we should be able to know right away what the x value is that maps to y. There shouldn't be any question. So that brings up, well, how do we find an inverse? Well, in this first example, of course, it's just a linear function, so it would pass the horizontal line test. We could check it with a graph, but I think we can all know that it does. And what that tells us then is, if I know what y is, I can find x. So I know most pre-calc books tell you to do it this way. They tell you to start by writing it as y equals, and then switch the variables. So we have x equals 5y minus 9. And then solve for y. So I'd add 9 to both sides. Divide both sides by 5. And that's my inverse. We write it like this. F inverse of x equals x plus 9 over 5. Now what this is the equation then that if I know what y is, if I came back up here and I said, well, I know the y value is 16. Okay, so y is equal to 16. What's the x value that maps to 16? Well, now I have a very nice function that would allow me to do it. 16 plus 9 is 25 divided by 5 is 5. You can see 5 times 5 minus 9 is 16. So this is a function for you know what x is, you want to know y. This is the function for you know y and want to know x. Okay, let's do another example. We'll do the same thing. Let's right away make that y. Let's switch the variables. X equals y cubed minus 6. Add 6. Cube root. So our inverse is the cube root of x plus 6. And of course, I probably should mention that because it's just the cubic function shifted down 6 units, it definitely would have an inverse. It would pass the horizontal line test. My last example, I've got x minus 2 over x plus 6. And please just note the domain here. X can't be negative 6, because of course that would make the bottom 0. Okay. So I'm going to start the same way. Make that a y. Change the variables. So x equals y minus 2 over y plus 6. I'm going to multiply, because I want to solve for y, I'm going to multiply both sides by y plus 6 so that I don't have to deal with that fraction. Okay. So now, if I multiply this through, I have xy plus 6x equals, those cancel out, so I have y minus 2. Now again, I'm trying to solve for y, so I want to get all the y's on the same side. So I'm going to subtract y from both sides so that I've got xy minus y plus 6x equals negative 2. I'd also, I got to get rid of this anything that doesn't have a y, so I'm going to move the 6x over. So I end up with xy minus y equals negative 2 minus 6x. I can factor a y out, left with x minus 1. Divide both sides by x minus 1. So my inverse is negative 2 minus 6x over x minus 1. Clean that up. Now one last thing I just wanted to point out, and this isn't overly important right now, but I want you to see, remember in the original equation the domain was x can't be negative 6. You learned some rules in pre-calc for finding the a horizontal asymptote. And the rules were, if the highest power is on the bottom, the asymptote 0. The highest power is on the top, there's no asymptote. And if the same power is on the top and bottom, you make a fraction out of the coefficients. Well, I want you to notice that we have 1x over 1x. So the asymptote is y equals 1. And in fact, y can't be 1. If you graph this, it doesn't touch its asymptote. So y can't be 1. So we have a domain and we have a range. Well, over here in the inverse, notice that the domain is that x can't be 1, because that would make the bottom 0. And the range, if we once again look at the powers, we've got an x on top and bottom, we make a fraction out of their coefficients, so negative 6 over 1, we've got y can't be negative 6. And what I wanted you to see there is that the domain of the original function becomes the range of its inverse, and the range of the original function becomes the domain of the inverse. And it makes sense. If we're switching x and y, it makes sense domain and range would swap.